we need to obtain the value of the given integral. So here the integrand is the dot product between the vector r with the first derivative of r with respect to t. So t here is a scalar parameter. So let's begin. So first we will use the definition. That means when we take the derivative with respect to t of the scalar dot product between vector r with itself, then this is simply equals to 2 times r vector dotted with the first derivative of vector r with respect to t. So here what we have done, we have assumed the first r vector to be function 1 and the second r vector to be function 2, and if we use the product rule, then this should give us the following result. So this is done such that when we take the integral with the limits going from 2 to 3, we have to compute r vector dotted with dr vector over dt integrated with respect to t. So this is the same as computing integration from 2 to 3. So we'll use this particular relation that we obtained. Let's call it number 1. So this will be half multiplied to derivative with respect to t of r vector dotted with r vector and integrated with respect to t. So we multiply with dt. So this reduces to half r vector dotted to r vector with limits going from 2 to 3. So r vector dot r vector, we know that when we take the dot product between a vector with itself, that simply equals to the magnitude of that vector r squared. Now that means here we'll have to compute, let me continue it here. So this will be equals to half multiplied to magnitude of the vector r squared, and it's calculated at the limits 2 to 3. Right. Now we'll come back to this. Let's call it number 2. We'll come back to this in a moment. So let's find out the magnitude of the vector r calculated at t equals to 2. So this is simply equals to square root of 2 squared plus negative 1 squared plus 2 squared. So this will be equals to, so we have square root of 2 squared, so that's 4 plus 1, 5, 5 plus 4 is 9, so we have square root of 9. So square root of 9 equals to 3, right? And when we square both sides, so we have the magnitude of r squared calculated at t equals to 2, that is simply equals to 3 squared, which will be 9. Then we'll calculate the magnitude of our vector r at t equals to 3. So this will be, so we'll square it as well. So this will be simply equals to 4 squared plus negative 2 squared plus 3 squared. So 4 squared is 16 plus 2 squared is 4 plus 3 squared is 9. So 16 plus 4 is 20, 20 plus 9 is 29. So this is the value of magnitude of the vector r squared calculated at t equals to 3. So that means now we can use this to value to calculate our part 2. So that means that will be equals to, we will come back. So we obtain the integration going from 2 to 3, r vector dotted with the first derivative of r vector integrated with respect to t. So we obtained this is equivalent to half multiplied to absolute value of the vector r squared with the limits going from 2 to 3. So this simply equals to half. So we'll use the upper limit here. We'll calculate the magnitude of vector r squared at t equals to 3 minus magnitude of the vector r calculated at t equals to 2. So this is a squared. So we have obtained this value. So magnitude of r squared calculated t equals to 3. So that's equals to 29 minus r squared calculated t equals to 2. So that's 9. So we have 29 minus 9. So 29 minus 9 is 20. 20 divided by 2. So that's equals to 10. So that means the value of this particular integral. So the value will be equals to, so this value is equals to 10.